So if you want to find the equation of a line that goes through 2 points or that has a certain intercept or a certain slope, there's two big ways you could do it. One way we do it is by putting it into slope-intercept form, which looks like y equals mx plus b. So that's probably the one you're most familiar with, where m is the slope and b is the y-intercept. But sometimes it's a little bit easier to get it into point-slope form, because for point-slope form, the only two pieces of information you need are still the slope, that m, but you only need any point on the line that you're given. So if you know at least one point and you know the slope, you can plug it into the point-slope form to get the equation that way. So for something like number 1, write the equation of the line that passes through 4, negative 8 and 7, 6. Well, they don't give me the slope, and I know for both of these forms I'm going to need the slope. So the first thing I do is I plug into the slope formula. So remember, the slope formula up top here is the change in y over the change in x. So if I let my first point be x1, y1, and my second point be x2, y2, then my slope formula is going to look like 6 minus a negative 8 over 7 minus 4. So 6 minus a negative 8 becomes plus 8, and 6 plus 8 is 14 over 3. So I now have the slope, and I have 2 points on the line. So I don't know what the y-intercept is, so it might be easier just to plug into point-slope form. Now remember, you could use any point for point-slope form, so I'm going to pick that 4, negative 8 there. So y minus a negative 8 becomes plus 8 equals m, which is my slope of 14 over 3, times x minus 4. Now this isn't the only equation you could have had for this one. You could also use that point right there to get y minus 6 equals still the same slope, 14 over 3, times x minus 7. Those are equivalent equations in this case. So for number 2, when it says write the equation of a line with the x-intercept of negative 8 and a y-intercept of 5, you might say to yourself, there's not enough information to do this one. So I'm going to just give myself a set of axes so I can brainstorm a little bit here. Okay, so it says that it has a y-intercept of 5, so it crosses the y-axis at 0, 5, because when I'm on the y-axis, my x value is 0. That's how I get that point right there. And it says it crosses the x-axis at an x-intercept of negative 8. So if I extend this a little bit this way, negative 8 is probably somewhere over here. So negative 8, 0. Well, now I do have 2 points. So if I plug into the slope formula to find the slope between those 2 points, I could just pick either of those points and plug in a point-slope form. So I'll do the same thing that I did for the last one. 0 minus 5, so subtracting my two y values, divided by negative 8 minus 0. When I simplify, I get negative 5 over negative 8, and two negatives divided by each other make a positive, so my slope is just 5/8. Again, when you plug into the point-slope form, it doesn't matter which point you use. So I'm going to use this negative 8, 0 here. So y minus 0 equals my slope, 5/8, times x minus a negative 8 becomes plus 8. So if I'm looking at the left side of that equation, y minus 0, I could probably just write that as y equals 5/8 x, and 5/8 times 8 is just 5. So you could leave it in either of these forms, whether it looks like this or whether it looks like the one on the top. Both of those are equivalent equations of that line. So for something like number 1, you might have the urge to subtract 8 on both sides and distribute that 14 over 3, and you absolutely could, but there's no reason to in this case. If you leave it like this, that's still the equation of the line. So for number 3, write the equation of a line with a slope of 0 that passes through the point -8, 7. Well, they gave us the slope and a point, so we could just plug in the point-slope form here. So y minus 7 equals a slope of 0 times x minus a -8 becomes plus 8. Now, if you think about the right-hand side of that equation, that's just going to turn into 0 because 0 times anything is 0. So it's really y minus 7 equals 0, or if we add 7 to both sides, y equals 7. So that one simplifies pretty nicely. Remember that when you have a line that has a slope of 0, so let's say this is the point that we want it to go through. If it has a slope of 0, that means the y values aren't changing at all. So that's some flat horizontal line. In this case, all the y values on that line are 7. That's how I get that equation of y equals 7. Sometimes I read that as y has to be 7, because that tells me that when I go to plot my line, all of the y values on all of my points should be 7 regardless of where I find them. For number 4, when it says to write the equation of a line that has no slope and passes through the point -8, 2, well, I'm going to give myself a set of axes again. -2, 8, let's say it's somewhere right about there. And if it has no slope, well, I can't say that that's a slope of 0 because they would have told me it was slope of 0. No slope, if you can't say it has any sort of slope, that's just a slope that's undefined. So the way I would think about that is that that's just a straight vertical line. And now you need to ask yourself, for a vertical line, are the y values changing or are the x values changing? So in this case, if I pick any point on this line, let's say this point right here, well, it shares the same x coordinate, we went left 2, but the y could be 3, it could be 4. If I go down here, it's still going to have that -2 as the x coordinate, and maybe -1 as the y coordinate. So the y values are changing, but regardless of where you pick your point here, the x value always has to be -2. So the equation for this line is just x equals -2. Remember that anytime you have a line that has a slope that's undefined, it's always going to be an x equals line. So for number 5, they want us to write the equation of the line through these 2 points right here. So remember, you either need the slope and the y-intercept, or any point and the slope. So I'm going to start by plugging into the slope formula again. My y2 minus my y1 over my x2 minus my x1. And I get 3 over 3, or just positive 1. So when I plug into using point-slope form, y minus, I'm going to use that point right there, y minus 3 equals, my slope is 1, times x minus 2. This is one equivalent form, or I could pick point B and do y minus 5 equals 1 times x minus 6. And both of these are totally fine. Even if you want to rewrite it in slope-intercept form, so if I want to distribute that 1 and make it y minus 3 equals x minus 2, and then add 3 to both sides, so that it looks like y equals x plus 1, you could absolutely do that too. Any of these 3 equations right here are perfectly fine. For number 6, write the equation of the line through m and n. So this is the same process. We take the points, we plug them into the slope formula, y2 minus y1 over x2 minus x1. Now negative 3 minus a minus 1 becomes plus 1. So negative 3 plus 1 is just negative 2 over 1, or just negative 2. Again, doesn't matter which point you pick. I'm going to pick point M. Y minus a negative 1 becomes plus 1 equals negative 2 times x minus 6. And for number 7, it's the exact same process. So when you do it all out, negative 3 minus 1 over negative 3 minus 4 is negative 4 over negative 7. Remember, a negative divided by a negative is a positive, so I could just leave that as 4 over 7. And I'm going to pick point B this time. So y minus a minus 3 becomes plus 3 equals 4/7 times x plus 3. Again, resist the urge to solve for y in these cases, because a lot of the times it's a lot easier to leave it in point slope form. Now for number 8, write the equation of a line with a slope of negative 3 and an x-intercept of 2. So, believe it or not, they give us enough information to do this one without even having to do any work. So it has an x-intercept of 2. So this point right here of 2, 0 is on whatever the line looks like. So if the line looks like that, it crosses the x-axis right there. Well, they gave us the slope and they gave us a point. So we could just plug it straight into point slope form. Y minus my y value is 0 equals slope of negative 3 times x minus 2. So this form is perfectly fine. Or if you wanted to distribute that negative 3 and rewrite it in slope-intercept form, it would be negative 3x plus 6. Both of these, again, are correct equivalent equations.